Course 3 Math, let me take a stab at lesson 115. We're working with triangles a little bit again today, talking about relative sides, relative angles. Relative means they relate to each other, right? So you have two triangles here. I'm going to jump to example 3 right away. And with these two triangles, they aren't facing the same way, right? We call that reflected because it's like looking in a mirror. They're reflected across this axis. But there are sides that match up, right? And the way we talk about sides is like this side right here, we put the two letters, doesn't matter what order, with a little line segment over top. So side AC, which one does side AC look like it matches up with in triangle 2? Looks to me like this side, right? They didn't make it too hard. So side WY is its relative side. Is it the same length? No, it looks shorter, but they match. If these triangles are similar, which we will determine shortly, then those are the sides that match. How about the bottom, CB or BC? In the first triangle matches with, let's use the same order, YX. And finally, the hypotenuse, side AB, matches side WX. What do you know about triangles? What do you know about their degrees? Unlike circles, which contain 360 degrees, triangles always contain half of that, 180 degrees. That'll be useful. We measure angles with a protractor, and we label angles with a little angle sign like this one. They always have that sign, even if they're obtuse. If I wanted to talk about this missing angle measure, I'd call it angle A, or you could call it angle BAC, or even angle CAB. Notice the point that you're talking about always has to appear at the center or by itself. Because if I said angle ABC, that would be talking about this one, angle C over here. Now, something that's true about angles, the largest angle in this triangle, it's not quite 90 degrees, it's 85 right here. The largest angle is always opposite, right? It doesn't touch immediately, but it's opposite from the largest side. The largest angle is always opposite the largest side. And by extension, the smallest angle will be opposite the smallest side. Because when you think about it, if you were opening up like a compass or something to create an arc, if you make this arc, you've opened it this big. If you open it wider, now you've got all this angle, then you're going to end up making a larger arc. It goes the same with triangles. The larger the angle across from that side, the larger the side. How do I know that these triangles are similar? While similar triangles will not necessarily have the same side lengths because they're just related, triangle angles will be the same size. In similar triangles, the angles will all match up. So angle ACB, which is 85 degrees, is the same as angle WYX. See that? And then we've got a missing angle here and a missing angle here. But if we can determine that all of these angles match up, then we'll know for sure they're similar. Right now, I only know one does. That's not good enough for me. But could we determine that two do? The first way I think of being able to do that is using our friend subtraction. Based on this fact, anytime you're missing only one angle measure of a triangle, you can always, by finding the difference, determine the missing angle, right? If there's 180 degrees total, and we already know 85 and 40, then if it follows the rules, the last one can only be one thing. Combine 85 and 45, you get 125. Plus what is 180? How do I find that? I subtract. 180 minus 125, right? That will give me this measure. $55. And now we know 1, 2, 3 match up. If I did subtraction, I would find that 180 minus the sum of these two would be 45. Okay, so everything matches up. Angle WXY and angle ABC match, and they are 45 degrees. Lastly, angle, I'm just going to use one letter to save time this time, angle A and angle W both equal 55. Okay, that was a slow review of things we need to understand about triangles to be able to do this today. It asks in example 3, if we know the length of AC, which they don't tell us, they're just saying hypothetically, if you knew the length of that side, how could we find the length of side WY? Okay, well, let's imagine that we do know the length of AC. Let's say AC is 6. Now, since we just proved with angles that, oh, look at that, it is 6. Ha, they do give it to us. Since we just established, because all the angles turned out to be the same, that triangle ABC is similar to triangle WXY. Now, if they're similar, that means they are in proportion. Meaning, how do I, we'll get to this in a moment. When I take matching sides, like 6 and the one we don't know, 6, and I'm going to just say WY so we remember which side this was. We put them across from each other in a proportion, and then we do the same for one more side. How about 8? 8 matches with one we know, 6. We have everything we need to be able to solve this because we've set up a proportion. Now, how do we determine scale factor for this example if we wanted to do that? You would just take from 6 to 8 or from 8 to 6 and divide, right? So if we want to go, what's the scale factor from 6 to 8? Right, we could take 8 divided by 6, and that tells me what the multiplier is, the factor. I'm just going to make sure I get my decimal right. 8 divided by 6 tells me if I multiply by 1 1/3, multiply by 1 1/3, I get to the big one. Now if I go the other way, what would I multiply by to get to the smaller one? Then I do 6 divided by 8, right? You'd have to multiply by 3/4 to go small. You were probably saying, I know what 6/8 reduces to. Sorry for taking the extra time. Okay. Now what I like to do is solve the proportion, which we learned to do by multiplying diagonally 6 times 6 and multiplying diagonally 8 times WY. You might choose to just use an X. So 36 is 8 times WY. How do I get WY by itself so I know what it's worth? I divide by 8, so I'm down to just 1 WY. And what is WY? It's 36 divided by 8, which I think is 4.5. Meaning, we have determined side WY is worth 4.5. Another way to do this is, like I was just doing with the thinking skill, if you determine, which direction are we going, let's go from big to small, so that we've got this same order. From big to small, the scale factor, or what you need to multiply to go from big to small, would be 6 divided by 8 is 3/4. Right? If you're getting smaller, you're going to need a number, a factor, a multiplier that's less than 1. With 3/4, if we thought of this as a scale factor, you could just use it to multiply. Multiply by any side that you want to match it to. So we determine, what does WY match with? It matches with AC. If AC is 6, all you do is use your scale factor times the known side from the bigger triangle. 6 gives you 18 over 4. Or divide top and bottom by 2. 9 over 2, which is 4.5. Same as this one, I just never reduced it. Also worth 4.5. 36 over 8 is the same thing as this. So that's how you can use relative sides and angles of a triangle. I think you are capable of doing A through D. We didn't talk a lot about the beginning examples, but I think with the review we just went through, you're going to be able to do that no sweat. All right, thank you so much. Best of luck.